Okay, so let's jump right into a really surprising connection. One that stretches across 300 years, linking a philosopher and a powdered wig to, well, the wild-haired genius who completely rewrote our understanding of space and time. We're about to see how pure philosophical thought actually predicted one of the biggest scientific revolutions in all of human history.
So here's our roadmap. We're going to start with this mysterious connection, then look at a supposed error Leibniz made. After that, we'll get into the really powerful ideas that paved the way for Einstein. And we'll even see why this whole debate from centuries ago is still helping to shape physics today.
All right, so how on earth does a 17th century philosopher meet the most famous physicist of the 20th century? Let's dig into the core of this incredible 300-year-old idea.
I mean, on the surface, it sounds a little crazy, right? Gottfried Wilhelm Leibniz died way back in 1716, long before Einstein was even a thought. But Leibniz was on this relentless quest, using nothing but pure reason to challenge the very fabric of reality. And in doing so, he ended up creating these philosophical tools that physics wouldn't be ready for another 200 years. Now, to really appreciate Leibniz's truly game-changing ideas, it actually helps to first see where his logic took him down a bit of a dead end. And that brings us to what's called his predicate in subject principle. Leibniz had this massive ambition. He wanted to prove that every single true statement is at its core just a definition. You know, like in the statement, a bachelor is an unmarried man. The idea of being unmarried is already baked into the definition of bachelor. He thought every truth, if you dug deep enough, worked just like that. But here's where it hits a wall. Take a super simple truth. The whole is greater than its part. Leibniz really tried, but he could not prove this just by fiddling with definitions. And why not? Because the relationship greater than isn't symmetrical like equals is. You can't just flip it. The part is not greater than the whole. It's what's called an irreducible asymmetrical relation, and it kind of breaks his perfect system. So his attempts to build this perfectly logical system had some, well, pretty bizarre consequences. It led him to argue that things in the world don't actually interact with each other at all. Instead, they're all just running on pre-programmed instructions from God, like two clocks that were perfectly synchronized from the beginning of time. It was a really ambitious idea, for sure, but it showed the limits of this one particular principle. But, and this is a big but, that error actually came from a much more powerful and successful idea. And this is where our story really gets interesting. This is the principle of sufficient reason.
Just let that sink in for a second. What Leibniz is saying here is truly radical. He's saying that nothing happens just because. Every single fact, every event in the entire universe has a reason, an explanation for why it is the way it is, and not some other way. This is basically the foundational rule for all of science and philosophy.
And here's what's really at stake. The only alternative is a universe filled with brute facts, things that are just true for no reason at all. And if you accept that, well, that's where curiosity goes to die. The principle of sufficient reason is the philosophical engine that demands we always keep asking why. It's what drives all of science.
Okay, so if you accept that everything must have a reason for being the way it is, that leads you to another powerhouse idea. This one has some really profound consequences for what it even means for two things to be different. This leads to a pretty startling claim. You can't have two objects that are perfect, identical duplicates, where the only thing different about them is their location. And why not? Well, because if their location were the only difference, there would be no sufficient reason for one to be here and the other to be there. For Leibniz, that's a brute fact, and he says, nope, not allowed. There has to be some other internal difference.
Now, this of course leads to a classic challenge, a famous thought experiment from a philosopher named Max Black. Imagine a universe that contains nothing, except for two perfectly identical spheres. Same mass, same color, same everything. They're only different because one is over here and the other is over there. So does this break Leibniz's principle? But here's the brilliant counter-argument. You see, to even imagine those two spheres, you first have to imagine an empty container, a pre-existing space for them to exist in. But that container, that idea of absolute empty space, is itself a brute fact. The thought experiment actually fails because it assumes the very thing that Leibniz is calling into question.
Okay, so we have two incredibly powerful principles on the table. Everything needs a reason, and no two things can differ by location alone. Now for the big payoff. let's see how these philosophical ideals build a direct bridge to 20th century physics and, you guessed it, Albert Einstein. So, back in the day, the dominant view of the universe came from Isaac Newton. For Newton, space was like this giant, invisible box, an absolute container that was just there, whether anything was in it or not. But Leibniz's philosophy points to something radically different. He says space isn't a thing at all. It's simply the set of relationships between things. Without things, there is no space.
And here it is. This is where it all clicks together. Let's just walk through the logic step by step. 1. Leibniz's principle rejects any difference that's based only on an external property, like a position in absolute space. 2. Okay, now let's apply that same logic to time. A universal now, a single moment happening everywhere in the universe at once, that would also be a purely external property. 3. Therefore, Leibniz's philosophy demands that a universal absolute now simply cannot exist. And 4. That is a philosophical heart of Einstein's special relativity. There is no absolute now. Simultaneity is relative.
I mean, the takeaway here is just astonishing. By following nothing but pure reason, Leibniz came to a conclusion that perfectly anticipated one of the most mind-bending discoveries in the history of physics. He argued that a single now for the entire universe was logically impossible, centuries before Einstein came along and proved it was physically impossible.
So why does any of this matter today? Well, this isn't just some fascinating footnote in history. This connection between Leibniz and Einstein really shows us the incredible, enduring power of philosophical reasoning.
So what are these key tools that Leibniz gives us? First, the demand that everything has a reason, no brute facts. Second, the principle that identity has to come from internal properties, not just external ones. And finally, the truly revolutionary idea that space and time are not some fixed stage, but are actually defined by the dynamic relationships between everything in the universe. And this is not just academic talk. Today, right now, leading physicists like Lee Smolin are explicitly using principles inspired by Leibniz as they tackle the next great frontier in physics, trying to unite relativity and quantum mechanics. These 300-year-old ideas are still right there on the cutting edge.
Which leaves us with a final big question. Leibniz challenged the common-sense view of space and time in his day using nothing but pure reason, and he turned out to be right. It really makes you wonder, doesn't it? What fundamental assumptions are we all making today that might just be brute facts, waiting for the right philosopher or physicist to ask the right question?